is a multi-way case where there are many partitions for a distinct value. So for instance, the example could be car type. It could be a family car, it could be a sports car, it could be a luxury car. So your criteria could depend on what kind of categories that you are having. Okay. So for instance, in the case of cheat, okay, you are dealing with someone cheating, right? And marital status could be single, divorce, and then married, right? We can actually combine these two also because they pretty much represent same type. Depends, you can actually have separate ones or combined together, single and reverse. So that's one way of splitting the nominal attributes. So binary split would be divide values into two subsets, um, but we can have multiple as well. For instance, here in this case we have seen in the example that we showed in a few slides prior to this, we showed that single and reverse have been combined, and we have found that that's the optimal way of splitting the data into just two types: single, divorce, and married. Not single, divorce, married. That means there are not three splits; there are only two splits in this case. It depends how many splits you want to have, and we'll call that as optimal splits. So that's also one thing you need to learn, or you need to understand, that how do we decide how many splits are to be do we going to have are we going to have. So here we have seen that sports and luxury cars, we just keep it one, and then family just one. But how do we come to know that this is a good one, or this is a proper way of doing it? Okay, it could be family or luxury of one type and sports of another type. So that we'll get to know only after looking the training data. Okay, so we want to optimize a matrix or a value, and based on that we'll do this division. So the idea is we'll just go with the split. We'll go with the split that maximize the division of our n variable or the class variable that we have seen. So the class variable in the case is cheat. So any classification that is more accurately able to give us the classification of someone is going to cheat, someone is not going to cheat, we'll then consider that classification to be the optimal one. Splitting could happen with the ordinal attributes also. Ordinal attributes, as I've said, it could be somebody who can be ordered, small, medium, and large. And similarly, the way we have seen in the nominal case, we can also combine some of the splits and find out what is the optimal one. How do we know? Again, we'll go with some sort of a cost function. We'll ensure that the split which is helping us classifying the data in a better way is the best split, and we'll find that out using some sort of an algorithm. Then splitting based on continuous. With nominal or ordinal, or in category case, it's easier. Whereas in continuous case, how do you know that? How do sort of use continuous variable to classify? Remember the example that we had taken. We had taken 80K as the splitting criteria. Someone with income after tax less than 80K and someone with more than 80K. How do you know that 80K? How do you know that this split value, or the value that splits these two groups? How do you come up with such a value or such a threshold? There are different ways of dealing with the continuous data. Discretization is the way to form an ordinal category attribute. That means income group can be lower income group, middle income group, higher income group. That's one way of doing it. Lower income group, middle income group, and then high income group. Okay, so based on somebody's income, you can categorize them into three types: lower class, middle class, higher class. You can have more classes also: lower middle class, lower class, middle class, higher middle class, and higher class. Okay, so you can have as many numbers you can, but just take the one that maximizes your classification chances. You could also do bucketing, something like income between $10,000 to $20,000, 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 and above. Okay, so that is some sort of a bucketing. So you have just, you know, 6 classes of income groups, and just see if that actually helps. You can combine, you know, make it just 4 classes or 3 classes, as many classes, which helps you, you know, classifying your data, that is whether somebody is going to cheat or not, in the best possible way. That's the way. Binary decision is taken based on a threshold value, like the way we have seen in the example. We have taken 80k as the threshold value. Someone with less than 80k and other criteria is not going to cheat. Somebody with greater than 80k and, you know, other criteria is included is going to cheat. So that's the idea here. How to come up with this 80k, this threshold value, using some sort of a split criteria or some sort of algorithm, and we'll see that how we come up with this. So taxable income 80k, yes or no, that's binary split. Multiple split, we have already explained. It could be the intervals, right? 10 to 50, 25, 25 to 50, 50 to 80, and greater than 80, less than 10. You know, could be 5 different categories. You know, that's the way you can actually use do the splitting. But it's not up to you to decide. Is you have to go with the splitting criteria that actually optimizes your optimizes the classification. The idea here is to get the correct prediction, right? If somebody is going to cheat, uh, your model should be able to provide the information before, you know, given his income, given his, you know, marital status and refund status, right? So that's the idea. So split will happen based on this, you know, end result, or based on this objective. Okay, so how to determine the best split? We have seen how to do splits, but how to determine the best split? The best split, finding out the best split is done before, you know, like this. We'll take an example. So here is the split. We have got 10 records with classes as 0. We have got another 10 records with classes as 1. So, you know, we have 0, 0, 0, such as 10 classes, 1, 1, 1, another 10 classes. And we have also got the attributes associated. One is owning car type, and then student ID. There are 3 different, you know, attributes given for this classification or groupings, and all you need to know whether it belongs to class 0 or class 1. So given somebody's car ownership, given somebody car type, given somebody's ID, student ID, we need to know if is 1 or 0, right? We'll use a decision tree for that. So which test condition is the best? Car ownership, car type, or student type? Now let's see the distribution of this 10 observation, 10, 10 observation, 20 observation, right? We have 10 zeros and 10 1, 20 observation within this category, right? So car ownership, yes and no. We can see that zeros in yes case is 6 and no case is 4, and no it's 4 and 6. Okay, so 4 people have cars and yes, 4 people have cars, 6 people don't have car. Am I right? No. Car ownership, yes, 6 people are 0 and 4 of them are 1. So that's 6 is to 4. Okay. If this is car type, you can see if it is family, then 1 and 3, sports, then 8 and 0, luxury, then 1 and 7. You know, more distribution, right? More 6 and 4, the difference is very close, right? The difference is only 2. Here in this case, you know, it's 2, it's 8, difference is 6. So the idea is that there should be maximum difference, maximum split, or between the categories. Okay, here student ID, there are 20 different student ID. You can see it's always 0, 1, 0, 0, 1, 1, 0, 0. That means the difference is always 1, 1, 1. That's not a good criteria. It has to be more than 1, right? You know, you simply cannot have just a 1 and 0 and take that as a. So this is a bad split, you know, bad attribute used for splitting. This is much better. Car type is much better. Car ownership is also okay, but not as good as car type, because here you can see the difference between the percentage of distribution is higher, and that should be the idea. So remember, we are talking about the cost function optimization. So here is the case. So the optimization happens in such a way that the difference in percentage of distribution should be high. Here it is 1 and 3, so difference is 2. 8 and 0, difference is 8. So that means there are 8 zeros and just 0 1. So difference is more in this case, and that's a good thing. Here it's also same. That's the idea. How to determine the best split? Okay. So the idea is the nodes with homogeneous class distribution are preferred. So all we need to know is the measure of node impurity. Okay. So that should be maximum distance between different nodes and minimum distance within the node. Okay. So within the node there should be minimum distance, whereas between the node that should be maximum distance. Okay. So we need to compute the node impurity to be able to find that. So here is the case. It's a non-homogeneous case. So see, zeros is 5, 1 is 5. It's not a good classification because the difference is 5 minus 5 is just 0. So we need to maximize this. Here in this is a good example. It's a homogeneous one where we have got, number of zeros is 9, number of 1 is just 1. So the difference is 9 minus 1 is 8. So that's good. That's better. That means the difference is, the difference is nothing but this distance. It has to be more and more. That's a better classification. So how do we measure the node impurity? So there are different matrices that is being used. One is Gini index, the other one is entropy. The third one, and a very popular one, is the misclassification error. So how do we find the best split? All right. So here is the one. The classification for 0 1 1 a priori, let's call that as n00 n01, and when with the attribute 1 and the different nodes you got some sort of a number, right? We have seen that in the previous example. Here also we got some sort of a number, right? So the idea is, we call that as m0, we call that as m1, m2, m3 and m4, and we combine this and you find m12, m34. The idea or the gain you get is what is the difference between m0 minus m12 and m0 minus m34. If you take the example in few slides before, it's very evident. Well, what is your m0? 10 records and 10 records. That means your m0 is just 1, right? Because they're the same numbers. Here if you calculate that, the difference is very simple, right? It is 2. Here is also 2, right? So it is okay, let me see. Okay, so this is some percentage of the total values, okay, and this is also some percent of the total value. Okay, this is 1 minus, it's just 2 by 10 plus 2 by 10. Okay, so this would give us some sort of a number. This would be 6 by 10. If you compute this one, this would obviously be higher. Okay, yeah. So the idea is that the distribution should be more uneven in nature. Here it is more even, here it is less even, and that's the way you find out what is the best possible split. So we find the unevenness, okay, and combine them and see initial distribution was this. After splitting, this is the distribution. How is the difference? Okay, whether there is a great difference or not. If attribute A is find out a great difference between two different splits, Attribute B is find out some sort of a difference. Which one is a bigger difference? See that and find out that's going to be the case. So how to compute impurity or Gini index? Gini index, as I've said, is one of the index that is used. Remember, impurity that we're talking about is nothing but exactly this one. Okay, so this is just a gain. There are different versions of it. One version is Gini. We calculate in this particular way. I'll not get into the details of calculation Gini, but I'll just briefly give you the idea what Gini is. And Gini is very popular index to find out the income distribution, right? You might have heard about income distribution. The idea is that with Gini index, we'll know whether there is a proper classification, right, or not. So it's 1 minus summation of P j given T whole square. So that's like the relative frequency of class J at node T. Okay, and you just square that and sum it across all classes, and subtract it from 1, and you get the Gini index. And we'll see how to calculate a Gini index. So here is an example. We have got C1 and C2. C1 is 0 and C2 is 6. So these are two nodes. Gini in this case is considered to be 0. Okay, and that's the best classification because the difference is more, right? 6 minus 0 is 6, so difference is more, so Gini is also more. Here difference is less, 5 1, so difference is 4, so Gini is more now. Okay, here the difference is even less, 4 minus 2 is just 2, so Gini increases. And here the difference is nothing, like 3 minus 3 is 0, so Gini is 4. So when Gini is 0.5, that means there is no difference between the classes, and that we do not want. We rather want this one because that is maximum difference, there is maximum classification. So somebody with Gini close to 0 is a preferred one over Gini close to 5. So Gini should be very close to 0 for a good classifier. And if Gini is very close to 0.5, then it's not a good classifier. So an example of computation of Gini, we have got the formula, so you can use it. Okay, here is the 0 1 1 case. So calculate probability of C1 because there are different probability for different classes with at a particular node. So this is node 1. So 0 divided by 6 is just 0, and probability of C2 is 6 by 6 because total is 6 by the way. Okay, 6 by 6 plus 0, right? So that's 1, right? 6 by 6 is 1. So how you calculate Gini is nothing but 1 minus probability of C1 square and then probability of C2 square, that's nothing but 0. Okay, that's a very good Gini, right? Close to 0 is better. You come here, calculate similar way, is 1 by 6, then 5 by 6, and then 1 minus 1 by 6 square minus 1 by 5 by 6 square, and it comes out to 0.278. So you know how to calculate. The idea is that something with a Gini close to 0 is the best one, or that should be the preferred one. Remember the attributes that we talked in the diagram. The attributes that has such Gini closer to 0 or higher impurity will be chosen first, and then it goes downwards. So splitting based on Gini. So based on Gini values, you can actually split. It's used in all such cases. When a node P is split into K partitions, the quality of split is computed like this. So this is just another formula to calculate what is the quality of the split, and that's one criterion used to find out what should be the number of partitions. There should be K equal to 2, 3, 4 or more. Okay, normally it is always 2 or 3 or maximum 4, not many partitions you would come across. Binary attributes. So how do we compute a Gini index in this case? Okay, so I've seen already how to calculate Gini index, right? So we won't get into details of how to calculate it again. You can also calculate Gini index for categorical attributes. So we knew how to do it for continuous, but we can also do it for categorical cases. Okay, and there could be multi-way splits and two-way splits. Like in the case of car type, so that's the way you calculate Gini index. Okay, so how do you do that? You calculate proportion and find it out. Okay, how do you do that? You find a proportion, right? I won't go into the details of it, but yeah. So all you need to know from this slide is that even for categorical attributes, you can use Gini index, and use that for splitting your data into different classes. All right. So here is the real example that we have seen. Taxable income greater than 80k. Yes or no? How do we come up with that 80? Remember, we had seen in that example, we can actually use Gini index to get into that. So how do you do that? So use binary decision based on one value. How do we come up with that one value? So we had one value is 80k. So the several choices are there. Like data we have got 10 choices, and every choice is a potential candidate for a split or for a threshold. So why we go ahead with 80? Why not anything else? Okay, why not anything else? Any number between the smallest and the largest one could be a potential threshold. How do we come up with that? So each splitting value has a count matrix associated with. Class counts in each partition is so what is that value for which you get the best classification, and that we have found out to be 80, and using Gini index you can find it out. So for each v, that means for each threshold, and threshold by the way can be any number in this income group. For each v, scan the database to gather count matrix and compute its Gini index. Okay, and based on the Gini index you find out where exactly your entropy is your impurity is maximized, or impurity is optimized, and take a decision on that. Okay, and we have found out that 80k is the cases where it is maximized. It's very computationally intensive because every number is just 10 number, but in real examples you will have thousands, 10,000 millions numbers, and calculating for each number a threshold value as a potential threshold value is very difficult. It's very computationally intensive, and that's not a big deal now because computational power of machines now has gone up drastically in the modern world. Like Gini, you can also use what is known as entropy. The formula I just changed, but the computation is very similar, except the fact that the reason why we have another matrix other than Gini is because we need to deal with computational efficiency. Okay, so entropy is just another improvisation from Gini, where the computational power has now improved a bit, depending on the case, of course. So entropy is just another way of finding out a criteria. The computation is very similar to what we have seen, except the fact that the formula has changed now. Right? You can see the formula was different. We were subtracting from 1 minus, but it's now changed. Otherwise, the calculation is pretty much the same. All right. So you can calculate the information gain with different splits for different attributes using entropy. So that's the idea. So Gini, entropy are the matrices that you would calculate to find out the information gain for every attribute, and how many splits are to be there for every attribute, and which one is to be given preference. How do you know the first node, and how do you go down to the tree? So that's the way you find out. You go ahead with finding out some sort of a splitting criteria. The third one we have seen is classification error, right? Apart from Gini and entropy, you can also use classification error. So classification error is also used like this. Classification error T is nothing but 1 minus maximum of probability of pi by t. T is just the node and I is the number of classes, probability of happening of the class. So you use misclassification error by the node. Misclassification is very easy, right? Somebody cheat yes and prediction is yes, it's not an error, it's matching. If it is yes but the prediction is no, then this is misclassification. So you go by that that number of splits which minimizes misclassification. Minimizes misclassification. That's the idea. Again, that is similar to what we have seen in other two matrices. Okay. So here is an example. How do you calculate this? Okay. So the probability of C1 in this case 0 by 6 is 0. Probability of C2 is 6 by 6 1. So error is nothing but 1 minus maximum of 0 and 1. Maximum of 0 1 is 1. 1 minus 1 is 0. Same, right? Easy. Probability of C1 is 1 minus 6. C2 is 5 by 6. Maximum that of is 5 by 6. So 1 minus 5 by 6 is 1 by 6. Right? That's the way you calculate the misclassification error. And yeah. So what we have learned so far is that Gini, entropy, and misclassification error can be used in order to be able to find out attributes, number of classification and thresholds in a decision tree. And that's exactly what is needed, right? Remember the slides that we have seen in the beginning? We were interested in these three. How to specify attribute test condition, how to determine the best splits. Now these two you can find out through calculating these matrices and applying. Of course, nowadays you don't have to do all these things because the computer gives you. If you're using R, SAS or a MATLAB, you don't have to do all these things. You don't have to calculate Gini, entropy and misclassification. It calculates it for you. All you need to do is that give your target variable, your class variable or target variable, and give attribute 1, attribute 2, attribute 3, all the, and it's going to give you the tree, final tree. You don't have to do all these calculations. So all that I have explained to you so far is for your understanding. Probably it's not in very detailed way, but I've tried to ensure that to keep it as simple as possible, as novice as I can, so that even someone beginner in machine learning or data mining should be able to understand what the heck is decision tree. So the final thing that we are interested in is determine when to stop. Now the tree can go on. It can go on and on. So how do you know? So where exactly is to be stopped? So we consider what is known as a stopping criteria for tree induction. So stop expanding a node when all the records belongs to the same classes. Now you go on classifying, but if these two classes have same cheat percentage, 5% here, 5.5% here, number of percentage of cheat, okay, I'm taking the same example. Cheating yes is 5% in this node and 5.5% this node. That is similar, right? That means this particular classification hasn't done much of a use. We can stop there. We probably stop below there also, but yeah, if you're a bit more serious about it, but you can stop here. So we'll just see that when exactly the classes down below in the decision tree do not have lot of difference in the distribution. Stop expanding a node when all records have similar attribute values. Okay. So if you have only cheat here and only cheat here as well, no point, right? There should be difference. Otherwise, there is no point in doing another classification, right? So will you classify something which is already classified, right? You know that this is already classified. So there are two trees. You find crosses here. You also find clauses here. Is this classification? No. That means we should stop there. We should stop this particular node. You don't even have to go below. Okay. This is classification is useful when you have something like this, or maybe just one. This is useful because they are all crosses, they are all zeros. But if they are all same, it's of no use, right? So that's the idea. That's the way you terminate something. Again, this will all be done in the software itself. We are using R. We're going to give you the stopping criteria directly. You don't have to, seriously go and look at the stopping criteria. It automatically does it for you.